Hello, boys and girls. My name is Sadie, and I am Miss Turney's puppy. Hi, sweet thing. And I'm going to help Miss Turney teach you today. Say hi. Say hi. Say hi. Hey, guys. This is Sadie. This is my puppy, Sadie. She's a Cocker Spaniel. You're almost having a birthday. Oh, she doesn't like this. You want to talk to my students? No? Okay. And she's down. Hey, everybody. Miss Turney. Coming to you from my house, obviously, as you can see. It is actually, what is it right now? Is it Monday night? Is it Monday night? It is, yes, it's Monday night. And I'm recording my lesson because my daughter started to not feel very well this evening and is running a little bit of a fever. And she has a little bit of a sore throat. So because of that, we're going to just be safe and take some precautions. And I'm going to stay home on Tuesday and go with her to go get a COVID test. I thought I would be just teaching you live, but I found out that for the first day that I stay home, for some reason, I have to teach you asynchronously. So I am going to tape today's lessons. Now for science, I'm going to tape what we're doing obviously today for science, but for social studies, you don't need any taped or video lesson. I talked to you guys yesterday about what we were doing in social studies, and in social studies, all you need to do is to click on the module for Tuesday and just pick up with that third video that we were watching, the one called Middle East, A Land of Contrast. I even put in the module, I think, to start the video at 3 something. That's about where I stopped it yesterday. So you can just click on that link to get to Discovery Education and get to that video. If it doesn't work, underneath it, I do have the instructions of discoveryeducation.com. Username and password is Hurst Hills, lowercase, no spaces for both, and then search for the video. There's specific directions on how to do that. All you're going to do is you're going to continue watching the video at your own pace in class. That way you can listen to it with your earbud. You can stop it, you can pause it, you can rewind it, and you can get all the answers that you need to. Remember that you're going to answer the questions that are on the page that we copied and pasted into our notebook yesterday. And then when you get done, be sure to take the quiz in Tuesday's module that is inputting your answers for those questions. So that's basically social studies. You don't have any kind of video that you need to watch for social studies. But what I'm recording now is your science video. And in fact, you know what? I actually need to write down what time it is because I need to make sure about, let's see, right now, my time, it is about 6:20 at night. So 20, 30, 40 minutes. I'll go for just, I don't know, for 20 minutes, 6:40, and then another 20 minutes, about 7 o'clock. So I'll maybe stop about 6:55. That'll give you plenty of time. All right, I'm just trying to figure out how long I need to make this video. All right, so anyways, coming to you from my house, this is my Christmas tree. This is like my front kind of room. We just put it up this weekend. And then my husband, as you can see, has those little like laser, I guess. What are those called, babe? Meteor lights. He has the meteor lights outside our house. Maybe if I remember at the end, I can take you outside and I can show you my house all lit up. But if I don't write myself a note, I'll forget to do that. All right, so the end of my video, maybe I can go outside and take a look. I'll write that down. All right, so let's take a look at what we are learning in science for today. All right, so I'm going to go ahead and I'm in a meet, and I'm the only one in the meet. I thought it would be interesting if someone popped in my meet, but we'll see what happens. All right, so I'm going to go ahead and I'm going to start presenting so that I can show you what it is we're doing today for science. All right, here's our science module. All right, 12.8, how do you show motion with a graph? How do you show motion with a graph? So you're going to just click on distance versus time graphing. Notice that the due date is the 9th. That is on Wednesday because it is an assignment that we will start today and that we will finish on Wednesday. And then notice that on Wednesday, it's the finishing of that particular assignment. All right, so go ahead and open it up. It says, what is the difference between a pie graph, a bar graph, and a line graph? Now, I know that we have used all of these in class at some point, especially when we just finished all of that, the data and the categorizing information on the Middle East, what we did last week. But you guys know that a pie graph is something that is a circle, and you can show percentages of that pie graph. I know that when we did the pie graph for the demographics of the Middle East, that's what we used for our religion. You know that a bar graph is something that has bars that maybe look something like this.
And that's what we used for, goodness, we used that for the, let's see, it was the literacy rate we used that for. And we also used like a sidebar graph for the ethnicity. But today we're going to be specifically talking about a line graph. And a line graph is a kind of graph that shows a progression of some sort, maybe something like this and looking something like that. All right, so let me show you what it is you're going to be opening for today. It's weird that I don't have two screens. All right, so let me show you what it is you're going to be opening for today. It says to give an example of a time when you use a pie graph, a bar graph, and a line graph. I just did that for you. I'm dropping everything on the floor. All right, so go ahead and open the embedded assignment below, right down here at the bottom. I'll give you some time to open that up. It's called distance versus time graphing. Distance versus time graphing. Now, you are not going to paste yours in your notebook. I am going to go ahead and paste it in my notebook because I don't have to do the whole thing and then turn it in. But you'll be doing that tomorrow. But I'm going to work with it from within my notebook. You work with it from within the Google assignment. All right, so this is what it looks like. It is four, excuse me, it is 4 pages. Distance versus time graphing. There's this page here, 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 and there. Now, I could have condensed this quite a bit, probably to 2 pages, but I would have had to make the graphs really small, and I did not want to do that, so I decided to go ahead and just leave it as 4 pages. All right, so we're going to get started. Here we go. It says, what is distance? Now, normally, if I were with you, this would be a time where I would stop and let everybody give me their definition of distance. But I think you guys know this is actually one of our vocabulary words, and we're going to go ahead and just type in. Now, some of the things I have over there on the side for you and some things I do not have on the side for you. This just happens to be something that I don't have on the side. So you'll need to type in the answer for what is distance. It is the amount of space between 2 people, places, or things. Now, there's actually lots of different, honestly, a lot of different things you can put down for distance, a lot of different definitions you could put down for distance, but this is what we're going to stick with. Amount of space between 2 people, places, or things. That works. All right, what are some units used when we measure distance? There are actually a lot of units that we can use to measure distance. In fact, I feel like sometimes distance is some of the most that we can use. But we have spoken about this before, about things that you can use to measure distance, different units. We use customary and metric here in the United States. We use the customary system. The rest of the world uses the metric system. But just some of the things that you could write down that we use for distance. We use centimeters. We can use feet, we can use meters, we can use miles, we can use yards. There's lots of different things. So here's just a few of the things that you can type in. All right, and then this is interesting. What is time? The definition of time. That seems like kind of like an obscure type of question. But what I came up with was a definition for time, and I'm sure there are lots of different definitions you can use for time, is how long it takes to get from one place to another. Since we're going to be doing distance time graphs, I'm going to kind of gear towards that type of definition. How long it takes to get from one place to another. Now, again, I'm sure you could get into some very deep and specific definitions for time, but this is what we're going to stick with for now. And then some units that are used to measure time. Units that are used to measure time. We'll start off with seconds. There are minutes, hours, days, lots of different ways to measure time. Centuries and millennials and light years is distance. All right, so there's just kind of the warm-up activity, focusing on what is distance and what is time. All right, here we go. Graphing activity. So you can show the motion of an object on a line graph in which you plot the distance against the time. On a distance time graph, which is what we're going to be focusing on for the next few days, time is placed on the horizontal axis, so horizontal, okay, this way, and distance is placed on the vertical axis. Vertical is up and down, horizontal is this way. Each axis is labeled as time or distance with the appropriate unit of measurement, abbreviated in parentheses. Example, if it was distance in centimeters, it would look like that. If it was time in hours, it would look like that. Each point on the graph represents the location of an object at a particular time. By plotting the data, the motion of an object can be analyzed. And then every graph must have a title. All right, so let's look at some of the information that I have over here, because we're going to move it over here and talk about some of the things that I just said. All right, so first of all, we're going to underline, we're going to use this one right here in green, that time is placed on the horizontal axis. So whenever we do distance time graphs, we are always going to put time on the horizontal axis. That means across the bottom, okay? And then we're always going to put distance on the vertical axis. That means straight up and down, okay? So horizontal for time, distance for vertical. And that's going to look like this. So the distance will always be on the vertical. And then the time will always be horizontal. I'll move that over just a little bit so it's not right there on that arrow. All right, so when you look down here at this particular graph that we're going to do, we would put distance over here on the vertical, and we would put time down here on the horizontal. All right, so here is what we are going to be graphing. Here is a chart right here. This is task 1. So the name of our graph is going to be task 1, because we always have to have every graph must have a title. So this is where we're going to be graphing task 1. So go ahead up here at the top and you can title it task 1. And you could change it. I don't remember what font I used. Maybe it was this one. I don't know if you have that one or not. There we go. Task 1. So that is the title of our graph, because every graph must have a title. Now here is what it is that we're going to be graphing. Notice that normally this could be someone who is walking or someone who is running, but at 0 seconds, this particular, we'll say person, was walking, and at 0 seconds, they had gone 0 m. Now, m in this case is going to stand for meters, okay? So in 0 seconds, they had gone 0 meters. By the time 1 second came around, they had walked 1 meter. By 2 seconds, they had walked 2 meters. At 3 seconds, 3 meters. At 4 seconds, 4 meters, and so on and so forth. By when they had gotten to 10 seconds, right here, they had walked 10 meters. So we're going to take the information that is in this chart right here, and we are going to graph it over here. So we're going to start first and foremost with taking a look at our graph right here. So here is our time, goes all the way to 10. And here's our distance. It goes all the way to 10. So notice that here is the distance. The distance has to go over here on the horizontal. And in parentheses right there, we're going to take that out and we're going to change the dash to M, not a capital M, or not a capital M, for meters. All right, so distance is meters. I always kind of try to put it right there in the middle. And then down here at the bottom, our time, according to the chart, the time is in S, in seconds. So right about there, and I'm going to change that to S. I had a line there because I was going to have you guys put that in. So our distance is going to be on the vertical, and that is in meters, and our time is going to be on the horizontal, and that is in seconds. All right, at this point, what we're going to do is we're going to put a dot. We're going to be plotting, and I know you've plotted on graphs before. We're going to be putting a dot at each point, okay? So right down here, I'm going to zoom in just a little bit. You'll notice that this graph goes to 10 on the time side and then goes to 10 on the distance side. And that should be plenty because right here, time goes to 10, distance goes to 10. So we're good right there. All right, so I've got a dot over here for you, okay, right there. You can use that dot if you want to, but you don't have to. I'm going to go ahead and just move it over here. And we're going to put this at the 0, 0, okay? We're going to put this at the 0, 0. Now, I'm about to zoom way in so you can see exactly where you need to put that dot, okay? All right, so there's the dot right there. I'm going to move it right there to the 0, 0, because at 0 seconds, this particular person had walked 0 meters. 0 seconds, 0 meters. All right, and then at 1 second, they had walked, I'm going to go up some further so you can see it. At 1 second, they had walked 1 meter. At 2 seconds, they had walked 2 meters. At 3 seconds, they had walked 3 meters. So let's take a look at what that would look like, okay? All right, so at 1 second, which is right here, this is 1 second, they had walked 1 meter. So it's almost like taking it and bringing it together, almost like what we did longitude and latitude. So you go seconds, goes up, meters goes this way, and where does it meet? That's where that dot is going to go, where it meets. All right, so you've got 1 second and 1 meter. So that second dot would go right there. 1 second, 1 meter. Bring it up and put the dot there. And then according to our chart, at 2 seconds, they had traveled 2 meters. So 2 seconds, follow that up. 2 meters, follow that across. Okay, 2 seconds and 2 meters, and plot that point right there. I'm just going to duplicate. And if you can't get, you need that crosshairs right there. If you can't get the crosshairs right there, just zoom in even more. And then you should be able to put it right there. And then at 3 seconds, this person had traveled 3 meters. So 3 seconds, 3 meters. So right here, 3 seconds, follow it up. 3 meters, follow it across. And you're going to plot your point there. 3 seconds, 3 meters. All right, so far, this is what we've got. Now we've got 4 seconds and 4 meters. Now we are starting with a very basic graph, okay? It'll kind of get a little bit more in depth as we do more graphs. This is a very basic graph. This is 4 meters, 4 seconds. So 4 meters, 4 seconds. And again, if you can't get those little crosshairs, because if I were to take this right now and try to move it, it would make the circle bigger, okay? So if you can't get those little crosshairs so that you can move it where you need to, just Control-Alt+, or zoom in however you need to, right there, 4 seconds and 4 meters. And then 5 seconds and 5 meters, 6 seconds and 6 meters. So you can see obviously kind of where this is going. It's going straight up right here, kind of in this diagonal line. So we're going to do 5 seconds and 5 meters, 6 seconds and 6 meters, 7 seconds and 7 meters. So that one would go about there. This one would go there because that's 6 seconds and 6 meters. Seven seconds and 7 meters. 8 seconds and 8 meters. 9 seconds and 9 meters, and then last 10 seconds and 10 meters, okay? All right, and this is what it's going to look like when you are done. At 1 second, they had traveled 1 meter. At 2 seconds, they had traveled 2 meters. At 3 seconds, they had traveled 3 meters, and so on and so forth. And this is where I've got these points, these plots on my graph. And at this point, this is where I would, and according to this, they stopped at 10 seconds and they were at 10 meters. So now I would just create a line and I would connect all of my dots. So I'm just going to take this line. I'm going to start right there. I'm going to bring it all the way to there. And you can make the line whatever color you want to. I'll just do this blue color right here. Okay. Actually, no, I don't think I'm going to do blue because we use blue for that other stuff. I'll do that purple color and make it just a little thicker so that you can see it better. Okay. But not so thick that you can't see the plots. All right. And then this is basically what you got. This is your graph. You just took the data on this chart right here and you just graphed it right over here. All right. So now what we're going to do is we're going to talk about what this looks like and what this is by answering these questions right down here at the bottom. Okay. It says, how would you describe the slant or the slope? That is one of your vocabulary words of the line on your graph. So if you were to describe this line right here, what kind of line would you say that is? Is it a straight line? Well, yeah, it is. It's straight. It's not wavy. Okay. Is it a vertical line? Is it a horizontal line? What kind of line is it? Well, we would call that a diagonal line. That is what was called a diagonal line. And it's a straight diagonal line. So it's not a diagonal that's kind of wavy. We would call this a straight diagonal line. I'm looking at the questions down here at the bottom. A straight diagonal line. So right down here in this answer, how would you describe the slant or the slope of your graph? We're going to type in straight diagonal line. Straight diagonal line. That's what that is. It's straight. It's diagonal. Did the object ever speed up or slow down during the 10 seconds? Okay, so imagine it this way. 1 second, I move 1 meter. 2 seconds, I'm at 2 meters. 3 seconds, I'm in 3 meters. 4 seconds, I'm in 4 meters. 5 seconds, I'm in 5 meters. Okay, every single second, they moved 1 meter. So they were pretty constant. They never sped up and they never slowed down. Okay, so your answer would be no. No, it did not. All right, so a straight diagonal line on a distance time graph indicates that the object traveled at a constant speed. Constant speed, okay? So that is a very important word right there, constant speed. Constant speed, all right, what does it mean for something to be constant? What does it mean for something to be constant? If something is constant, that means that it doesn't change. It always stays the same. Now, on this particular type of graph, which is a distance time graph, because if you look right here, it's a distance versus time graph. A little bit later, next week, we'll be looking at a position time graph and a speed time graph, and that is different. But for a distance time graph, constant, okay, what does constant mean? Constant means that it stays the same or doesn't change. And that's this next question right there. It says, what does constant mean? You can answer, stays the same, ... doesn't change. Stays the same, doesn't change. All right, and it says during any 1 second of time, the object moved how far? All right, we'll say in 1 second, it was 1 meter. In 2 seconds, they were at 2 meters. In 3 seconds, 3 meters. 4 seconds, 4 meters. So basically, every step or every second that went by, this particular person moved 1 meter. In another second, 1 meter. In another second, 1 meter. So it says during any 1 second of time, the object moved 1 meter. Object move 1 meter during any 1 second of time. So then it says, what is the speed of the object? So what we will need to be able to do is then take a graph like this and figure out what the speed is. Well, we know that speed, okay, is distance divided by time. Speed is distance divided by time. We've talked about that many times. So we've got to figure out what was the distance of this particular person and how long did it take them to get there. So if we look on our graph, the distance that this person went, right, the furthest distance was 10 meters, okay, 10 meters. So we could take in our graph, not our graph, sorry, our formula down here at the bottom, okay, and we could say 10 because the distance was 10 meter was the distance, divided by the time. How long did it take the person to get to 10 meters? It took them 10 seconds. So then we would do 10. 10 divided by 10. 10 divided by 10. And what is 10 divided by 10? It is just 1. 10 divided by 10 is 1. So the speed of this particular person was 1 meter per second. Okay, the speed was 1 meter per second. So for every second that passed, this particular person moved 1 meter. So 1 meter at 1 second, and by 2 seconds, they were at 2 meters, and by 3 seconds, they were at 3. So every second, they moved forward 1 meter, 1 meter, 1 meter, 1 meter. Okay, now that would be considered a constant speed. That would be considered a constant speed. If you look right here, this is a straight diagonal line. Okay, a straight diagonal line means on a distance time graph that they traveled at a constant speed. So right over here on the side, this is what you're going to do. You're going to bring this right here, and you're going to bring this right here, and put it right inside of it. All right, so a straight diagonal line that looks like this, the one that you see right here. If you see a straight diagonal line on a distance time graph, it means that that particular object traveled at a constant speed. It means that that particular object traveled at a constant speed. All right, so here we go on that. So what we did was we started off by naming our graph, task 1. We put our distance right here on the horizontal at meters, because according to this graph right here, it was at meters. I guess that could be miles, but we're going to do it with meters. And then time down here on the horizontal, sorry, that was the vertical, horizontal, in seconds. Then we took and we said, okay, at 0 seconds, they were at 0 meters. We put our dot. At 1 second, they were at 1 meter. We put that there, 1 and 1 meeting together, kind of like latitude and longitude. And then we just plotted our points all the way up according to this information. We drew our line, and then we stepped back and we looked and we noticed, hey, that's a straight diagonal line. A straight diagonal line means a constant speed because this particular person went 1 meter every single second. Okay. All right. So now we're going to move on to the second page, task 2 with the second page. Now, if you don't have something and you need to pause it, go ahead and do that now so that you can get all of your answers there. All right. Here is our second page. All right. So this is task 2. Task 2. So you've got seconds again and you've got meters again, but this time you have from 0 to 10 seconds. So still just 10 seconds, but look at the distance. This time, this person went 50 meters in 10 seconds. So the other one had only gone 10 meters. This one went 50 meters. So if you look at the graph, you'll notice I have done 1 to 10 because it goes to 10 seconds. But here I've gone to 50. Okay. notice 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, because the distance has to go up to 50 on this one. Whereas earlier on this one, the distance only had to go to 10. So be careful when we're plotting our points on this one that this is not counting by ones over here. All right, so we're going to start off by giving it a title. The title is Task 2. That's pretty simple. So I'm just going to type here at the top, Task 2. You want to make it stand out in bold, you can, but you don't have to. All right, Task 2. There we go. Now we've got to put our distance and our time, always distance over here on the vertical, time goes across the bottom. Did I put that over here? I did. All right, so here's the distance right here. I'm going to move it over to the vertical. We are, again, doing M, so we're going to do meters. Make sure that you change that dash, dash, dash to meters because I left it. That was kind of like blank. I'm leaving it blank so you can fill it in. And then also across the bottom, across the horizontal is going to be our time. So move that there. And according to the chart, it is in seconds. Now, you will notice that starting tomorrow, we'll do and use something other than meters and other than seconds. All righty, here we go. So we are going to now plot these particular points right here. Okay, I've got the dot. Where is it? It's down here. You can use this dot if you want to, but you don't have to. I'm actually using my, my arrows to get it where I need it. Okay, here we go. This is different. We've got 0 seconds and 0 meters. That's always easy to do. I'm going to zoom way in. If I click off of it and get all the blue bars gone, then I can grab it like that. There we go. All right. In fact, I think what I'm going to do is I'm going to duplicate that. I'm just going to put it over here and I'm going to make a bunch of them. Okay. All right. So now let's go to our next point. Our next point is 1 second. They had traveled 10 meters. After 1 second, they'd gone 10 meters. Okay. So here's our 1 and here's 5, 10. So we've got to take 1 up and 10 across and put our point where they meet. So after 1 second, they had gone 10 meters. Okay. 1 second, they had gone 10 meters. All right. After 2 seconds, they had gone to 20 meters, not another 20 meters, but 20 meters. So here we go. So here's our 2 seconds and here's 15, here's 20. So you'd follow this across, follow the 2 up. So 2 seconds and 20 meters. So that one would go there. Okay. So at 1 second, they had gone 10 meters. At 2 seconds, they had gone 20 meters. And I can see that that's not perfect, but I'm not going to be super worried about that. There we go. That's better. All right. At 3 seconds, they were at 25 meters. At 3 seconds, 25 meters. All right. So here we go. 3 seconds right here. So you'd follow 3 seconds up and then 25 across. So 3 seconds and 25 meters right there. Here we go. All right. At 4 seconds, they were at 25. What? So at 3 seconds, they were at 25 meters. And at 4 seconds, they were still at 25 meters. And then at 5 seconds, they were still at 25 meters. Isn't that interesting? All right. So that means that at 3 seconds, they were at 25 meters. Okay. It says at 4 seconds, they were at 25 meters. And then it says at 5 seconds, they were at 25 meters. That's interesting. Those are supposed to be together, but close enough. There we go. We'll just do that. Well, that's interesting. At 3, 4, and 5 seconds, they were still at 25 meters. So 25 meters, 25 meters, 25 meters. Okay. Well, that's what the chart says. At 5 seconds, they were at 25. We already did that one. At 6 seconds, they were at 30 meters. All right. Well, now there we go. So at 6 seconds, which is right here, they were at 30 meters. So 6 seconds, 30 meters is right there. 6 seconds, 30 meters followed across. All right. At 7 seconds, they were at 35 meters. So I know this line right here is 7 seconds. I'm just way zoomed in, right? So at 7 seconds, they were at 35 meters. At 8 seconds, they were at 40 meters. All right, I know this line right here is 8 seconds. They were at 40 meters. At 9 seconds, they were at 45 meters. All right, so I know that if this one was 8, this one is 9 at 45 meters, and then this one is 10 at 50 meters. Now, I'm zoomed way in so that you can see it better, okay? But let me zoom out and just make sure that I followed it correctly, okay? Let's see. There's the 10 seconds right here, 10 seconds at 50 meters, 10 seconds at 50 meters. Yes, it is. All right, now that looks quite different, doesn't it? That looks very different from what you saw earlier. Okay, at this point, I think I might be past my time period of 45 minutes, but that's okay. You're just going to have some homework, and that's just going to be the way it is. So if you don't finish this in class, just pause the video and pick it up, because we could definitely need to make sure that we finish these 2 pages. All right, here we go. So as you can see, this is quite different, okay? So we're going to go ahead and we're going to draw our lines, and we're going to connect our dots. We're going to connect these 3. But as you can see, we kind of have to stop it right there, okay? We can't go there because we don't get that point if we do that. So we have to stop our line right there, okay? And then we have to create another line, okay? We're going to create another line from here to there. Oh, why did I make that blue? All right, now we have to create another line from here to there. So this is obviously, if we had a pencil, we would be doing this really, really quickly. But since we have to do it on the computer, it doesn't work that way. And then another line from here. It looks like we can just go straight diagonally up. Yes, we can. All right, here we go. So there's our last line from here to there. All right, so that looks different, doesn't it? It does. So we've got kind of a line that goes here, a small one from there to there, one that goes there. And I'm going to make all of these a little thicker just so that you can see them better. Okay, that's what we've got. That's our graph. All right, so let's kind of take a look and analyze this graph to see kind of what that means. All right, let's look down at the bottom. Here we go. All right, how would you describe the slant or the slope of the line on your graph? It's something, then something, then something, because this is definitely not just one line from there to there. There's kind of like 3 different parts of the line, okay? So right here from there to there, that is a diagonal line, okay? But that's what I would call a very steep diagonal line, okay? Because it's really very steep up and down. So if this were a diagonal line, this would not be very steep, okay? If I were going to be walking on a hill that's this steep versus walking on a hill that's this steep would be completely different. So this is what I would call a very steep diagonal line, okay? So we're going to type that in right there, steep diagonal. Which is this area right there. But then what happens right there? Check that out. What kind of line is that? Okay, that's a flat horizontal line. It's a straight, flat, horizontal line across, okay? So we've got a steep diagonal, then we've got a flat horizontal. And then this one right here would be just a straight diagonal line, that perfect straight diagonal line like we saw on the very first graph that we did. All right, so 3 ways to describe this graph. First, it's a steep diagonal. Then it's a flat horizontal. And then it's just a straight diagonal line like we saw on that first one. Okay, that's how I would kind of describe what's happening in that particular graph right there. Did the object have a constant speed? So when we talked about the constant speed, like with this one, the straight diagonal from beginning to end, does this one have that straight diagonal from the beginning to the end? No, it does not. Okay, so it does not have, our answer is no. Okay, and the reason that you know it doesn't have a constant speed from the beginning to the end is because it's not a straight diagonal. It doesn't have that perfect straight diagonal line from the beginning all the way to the end. It kind of does some weird wonky things. Okay, so I'm going to just duplicate this so I can put not a straight diagonal. The reason that we know it's not a constant speed is because it's not a straight diagonal line. This is an interesting question. What happened to the object's motion between the 3rd and the 5th second time interval? Okay, so at 3 seconds, at 4 seconds, and at 5 seconds. So looking right up here, at 3 seconds, at 4 seconds, and at 5 seconds. What happened to that person or that whoever it was? They were at 25 meters, 25 meters, 25 meters. At 3 seconds, 4 seconds, and 5 seconds. So what did they do? They stopped, okay? Because they were at 25 meters, 25, they stopped. They had to have stopped for some reason. I don't know, maybe he bent down, tied his shoe. I have no idea. But for some reason, this person stopped at 3 seconds, at 4 seconds, and at 5 seconds, they stopped. They stayed at 25 meters, 25 meters, at 25 meters. We don't know why. All we know is that they did. They stopped. I'm going to put right here, what did they do? Stopped. Don't know why. All we know is they were at 25 meters, 25 meters, 25 meters. For 3 seconds, they were at 25 meters. All right. And then it says, what is the average speed of this object? So in order to find the average speed, you've got to take the total distance divided by the total time. Okay. And according to this graph, the total distance that they went was 50 meters, and the total time it took them to get there was 10 seconds. Okay, so right down here, we're going to put that right here. All right, they went 50. Okay, they went 50 meters. And it took them 10 seconds. Distance, time. Distance, time. Distance divided by time. Okay, so here's the time goes there. Distance goes on the inside. I had several students who got this confused last time. What is 50 divided by 10? 50 divided by 10 is 5. 50 divided by 10 is 5. So what was their average speed? The average speed was 5. They weren't always going 5, okay? But 5. 5 what? 5 meters per second. 5 meters per second. Now remember, this says average speed. Average speed. They weren't going 5 meters per second the entire time, but they were going 5 meters per second was their average speed. Oops, what did I do? I took that off. How do you, oh, I didn't, oh, let's see what I did. When I duplicated that, maybe I didn't duplicate it. There we go. All right, so let's talk about what we're going to do with the stuff over here on the side. All right, so one of the things that we really noticed this time was this particular area right there, okay? This flat line. All right, so what that means, a flat horizontal line on a distance time graph, and it looks like I need to make this thing right here maybe a little bigger. There we go. A flat horizontal line on a distance time graph means that they stopped, okay? Somehow they stopped. For some reason they stopped because 25 seconds, not 25 meters, 25 meters, and 25 meters. All right, so that means that they stopped. Now I'm going to show you how to draw this little kind of curvy line right here. All right, so if you come over here, because we're going to point to this area right here. I'm going to put the stop sign right there. Okay, so we're going to point to this area, come up here and do scribble and simply start somewhere right here, drag and click, and then let go right about there. And it'll give like kind of a curvy line. Okay, I'll show you that one more time. You choose scribble, and when you click, you hold it down and you just point to this area right there. And I'm going to make it red, and I'm going to make it really thick. And I'm going to point to it. Now, I want to put on this little place right here on the very end, I want to put like this little arrow. So if I click on that and choose, is it line end is what I want. And I want it right there. I want that little arrow. And it points to that little arrow right there. So what this means, that little area right there, I guess we can circle it as well, right in through here. What that means is that the person stopped. So if you ever seen a flat horizontal line on a distance time graph, it means that the person stopped. That's what that indicates. All right, so I'm going to zoom out so that you can see this. And that's where we're going to stop at that point right here. From my understanding, I will be able to teach you guys live on one Wednesday. Okay. Now I could be back on Wednesday if my daughter gets her test back and it's all negative and we're good to go. Right now we're still trying to find a place we could do the rapid test. So that's just kind of what we're waiting on. But my hope is to be back with you on Wednesday in class. But if not Wednesday in class, then I hope to be back with you on Wednesday, at least live. So let me know if you have any questions. There's nothing that you need to turn in at this point. Okay, you're not turning anything in at all whatsoever. You just need to, I'm going to stop right there. You just need to get to that point and let me know if you have any questions. And my plan will be to be back with you either on Wednesday live and in person or Wednesday here live with you like in class. So I'm sorry we ran out of time. Let's see if I can show you my lights outside. My husband works really hard and does all this. Let's see. Can you guys see me? Let's see if we can. All right. My husband is what you would call a Griswold. So if you've ever seen the movie Christmas Vacation, yeah, my husband is that guy. Okay, he's that guy that loves to decorate with Christmas lights. So I just have, I don't know if you can even see all that. I just have lots of Christmas lights, and this is just like the very. Yes, it just keeps going and it keeps going and it keeps going and it keeps going. And there's a little snowman family like over there, a little snowman family. Anyways, my husband is crazy when it comes to lights. So hopefully I'm not making you too dizzy. Hey, Sadie, you want to say goodbye? Sadie Belle. Sadie. I guess she doesn't want to say goodbye. All right. Let me know if you guys have any questions, and I hope to see you on Wednesday. Bye-bye.